Hello, I am Rabi, and this is How to Pass Integration Core Skills. This is just going to be a short lecture. We're going to go over all of the question types in the core skills, and I'm going to show you how to solve them. And feel free to ask questions during it as well. So let's go ahead and start with the first question. It is the Riemann sum. I'm just going to screenshot an example question right here. So evaluate the Riemann sum for such and such a function with 5 subintervals, taking the sample points to be the right endpoints. And this is kind of ambiguous to what they want you to do if you haven't done it before. But the graph kind of helps with that. So we're actually not going to do the first part first. So here, this is the entirety of the question. And we're going to work out what the answer is right there. So, first we're going to have a look at the graphs. And we can see that for B and D, those are definitely going to be wrong because the bars are just like over here. What's this? This is like not under the graph, between the graph and the x-axis. So we can tell that B and D are definitely going to be wrong here. Then the question is between A and C, which one's correct? And we can see here they say they want the sample points to be the right endpoints. And that means that the points on the graph should be at the right-hand side of these rectangles, of the area they're calculating. So the correct answer here would be C, because if we look at A, they've taken the left endpoints. So now let's kind of go back to the actual first part of the question.
If I'm being dumb, but what did you mean by right endpoints? Could you explain that bit again?
Sure. So what they have here is they're calculating integration by taking the area of a couple of rectangles under the graph. And maybe I've actually explained this the wrong way around. So say they've taken the value of the function at -6, and that's over here. And then they've taken the value of the function -4, and that's over here. And then -2, and that's over here, and so on. Then they have to decide, are these values going to be the left corner of these rectangles or the right corner? Because it has to be one of the two. So for taking the sample points to be the right endpoints, they decide that those values are going to be the right corner. So what this first bit really means is, if I can't pan around now apparently. There we go. That we're taking this function and we're evaluating it at 5 places. And to figure out how far apart these places are, we're going to take the range, so that it's between -6 and 4. And we're going to divide this range by 5. So that is, the difference between 4 and -6 is 10. So 10 over 5 is 2. So we know that these points are going to be 2 apart. So now let's start from -6 and keep adding 2 until we get to 4. So we get -4, we get -2, we get 0, 2, and 4. But the keen members of you may have noticed that that's actually 6 points and not 5. And that's where this thing of the right and left endpoints come into play. Because if you wanted the left endpoints, then you're taking the value at -6, the value at -4, the value at -2, the value at 0, and the value at 2. And not thinking about the value at 4. Whereas, if you're looking for the right endpoints here, you're taking the value at -4, the value at -2, the value at 0, the value at 2, and the value at 4. So they are asking for the right endpoints, and I think they always ask for this. So we are just going to get rid of the -6. We don't need that. So now what we have to do is evaluate the function at all of these numbers and add it together. And the function was 3 minus 3x. I'm terrible at writing this, but...
I understand this.
Sorry?
No, you're doing great. You're doing
Okay,
awesome. Go
awesome.
for it.
So let's keep going then. We're going to evaluate the function at all of these values and add them together. So it's going to be 15 plus 9 plus 3 plus minus 3 plus minus 9, is that what it is?
Yeah.
There we go, it is minus 9. So we add these together and we get 15. Oh, I undid something I didn't mean to. So that's 15. And now we're going to multiply by the value all the way here that we calculated was the difference between the two. And the reason for that is we've calculated the height of these 5 rectangles, right? And we've added them together. But what we really want to know is the area of all of these rectangles. And to find that, we need to multiply the height by the base, and the base is 2. So we're going to do 15 times 2, which is 30. And that is the answer for part 1. If we want to, so evaluating the Riemann sum, the answer is 30. And we already went over why the graph is part C. And I might go over another one of these in detail later, but for now let's move on to the next question, which is another annoying one. They give you a table of values for a certain function, and they want you to find the lower and upper estimates for the integral of the function. And having not seen this before, I had no idea what to do until I actually looked it up. So this is actually kind of similar to what we've just done. What they have is they've evaluated this function at certain places. Let's just sketch this. So at 0, we've got it's up at 11. Then, hold on. At 0, the function's up at 11. At 4, it's at 8. At 8, it's at 3. At 12, it's at minus 4. At 16, it's at minus 13. And at 20, it's at minus 24. And they've got these points. And now what they want to know is they want you to find the areas contained within some rectangles. Do they want the rectangles going like this, where the edge of the rectangle touches the function at the left point? And in that case, we don't actually know. I don't know what I was going with there. Do they want it at the left point, or do they want it at the right point? In which case, it would look something like this, which is kind of different. And the answer is that they actually want you to do both. So in this case, the function is decreasing. So the upper estimate is going to be the one which is higher, which in this case looks to be the one where it's at the left endpoint. And the lower estimate's going to be the one which is lower. So the way we work this out is actually kind of simple, the computation. All we're going to do is discard one of the values on the end, then add up all the other values, and multiply by the difference in x. So let's say we want to find one of them. We're going to discard this last value, the value at x equals 20. We're going to go on and just add up all the others. So 11 plus 8 plus 3 plus minus 4 plus minus 13. And I'm terrible at arithmetic, but that gives you 5. Now we're going to multiply that by the difference in x, which we can see is 4. They've added 4 every time. So we're going to go ahead and do 5 times 4, which gives us 20. So that is one of them. Now let's go back to the actual table. Let's say no, we want to keep this value, and we're going to discard the first value. So we're going to add together all of the other ones. We're going to repeat this step, but for the other ones. So I'm not going to write that out because I don't have much space here, but I'm just going to add together 8, 3, minus 4, minus 13, and minus 24. And that gives you minus 30. And I'm going to multiply that by 4, which gives you minus 120. So you've got two answers here. We have 20, and we have minus 120. And they asked for the lower and upper estimates, and that's what we've got. So the upper estimate would be 20, and the lower estimate would be minus 120. And all you want to do is make sure you put those in the correct box on the quiz. Like, if you calculated it in the order that I did, you might be tempted to write the 20 in this box, which would be wrong. You have to make sure that you put them in the right box there. So I think this one was decently okay once you get the method. Let's move on to the next one, which is then integration of a piecewise function, maybe. Let me see if I can actually remember how to do this one.
Just split it into 2 integrals.
Yeah, I think...
So you have an integral from 8 to 6, and you have an integral from 6 to minus 8.
Alright. So we have the integral between minus 8 and 6 of fx, and we're going to add the integral of between 6 and 8 of fx. And we can kind of visualize this using a graph that fx, it is for all x less than 6, we know that fx is going to be minus 4. And then for all x greater than 6, it's going to be at x minus 10. So 6 minus 10 is minus 4. And then 7 minus 10 is going to be minus 3 and so on. So it's going to go like that. And actually, I think the way I answered this question in the quiz was just by working out the areas. I feel like there's a better way to write that down using this notation, but that's not what I did. So what I would have done is literally just minus 4 times the difference between minus 8 and 6, which is 14, plus 2 times... Oh, actually, since we're dividing it by 2 anyway, the 2 doesn't matter, but oh well. Minus 4, isn't it?
Yeah.
And... hold on. At 8... I'm doing this wrong, aren't I? I'm doing this wrong. Because at 8, the value of the function is 8 minus 10, which is minus 2. So we've got over there... this was minus 4, that was minus 2. So we've got a minus 2 times 2 divided by 2, which is kind of redundant, but oh well, plus a minus 2 times 2. I can try drawing that out better, actually, because I did this question in a terrible way. This was the one question I actually forgot was on the test, so I kind of forgot how to do it. So that's the 6. That's the 8. And what I've done is kind of split this area into 2 parts. The triangle and the rectangle. And then worked out their areas individually and added them together.
So do we want to do it the proper way or no?
Honestly, I feel like the proper way is probably smarter to do. Let's paste the question again. So we're going to split that into the 2 integrals between -8 and 6. And 6 and 8. At this point, I don't even know what the next line of working is. What do you write
You
here?
just replace f of x with like the corresponding function.
Right.
where
Is
the
that all you
graph
do?
is yeah, so where it's between -8 and 6, it's equal to -4, and then the other
Right.
one is equal to x take 10.
Yeah. Okay. Oh, all right. And then, of course, we have a between 6 and -8, -4x, and between 8 and 6, we have x squared over 2 minus 10x. And this is starting to get annoying, which is probably why I decided to just do the area. So we have take away -4 times -8 plus
Yeah, this is pretty bad.
yeah, this is. You have to write out all of this. Like, come on. Take away 6 squared over 2 minus 10 times 6. I feel like I'm about to make some kind of arithmetic mistake here because of how much stuff there is on the screen right now. There's a -24 minus a 32.
Yeah.
And there is a another 32 in here. Take away 80 for some reason. Minus a
18.
18, right. I was thinking it was 17 for some reason. It's an 18. Take away 60. And now if we do this, we have a minus 56 plus minus 48 minus 42. Which would seem to suggest that we have minus 56 plus...
-6.
Yeah, -6. Wonder why I was saying plus there. It's a bit silly. Plus 6, which gives us minus 50.
No, it's plus -6.
Oh. So it was a -6, right?
Yeah.
Oh, right. Because, yeah, I'm just trying to skip the working here, guys. Plus, yes, the -6 in there. So, all we get at the end is a minus 62. And that, I believe, was the correct answer, yes. So that's two ways you can approach the question. You can either do all of this working, or you can do this geometry, which is slightly less sound. Now let's move on to a slightly strange one. Evaluate the integral by interpreting it in terms of areas. So here we're going to paste one which I actually got wrong. And let's see if I can get it right this time. So, this one is kind of annoying. What I like to do is try and just work out all the areas in the graph and add them up. It shouldn't be too hard, but this one, the massive gotcha for me, was the fact that all of the scales are in 2. So both the bottom and the top scale is going by 2. So a box is 4, even though it's like shaped weirdly, which for some reason made my brain think the bottom was 1. So if all of these boxes are 4, these are both half of a box each, and these are a quarter of a box. These two, since that's just a triangle with height 2 and base 4, that just adds up to 4. This is a -2 over here, and that's a 1. And if we add all of those up, we seem to get 25. And this one I don't actually have the correct answer for.
That's what I got, but did you miss like the small triangle in the middle?
Which bit? This? No, I counted that as part of that. Should have made that clearer though. Yeah, because I did this as like a triangle.
Sure, yeah. I got 25 as well.
Yeah, I'm pretty sure that's 25. We can just do another one where I do have the right answer though, just to make sure.
I can give you my one if you need it.
Grabbed another one off the core skills tests. Let's meme with it. So what we have here is now the scale is all 1s, which is annoying, because I keep an eye out for what they're actually going to set the scale as and not get fooled like I was. So that's just, these boxes are all just 1s. This again, I'm going to consider that as like a triangle of base 2 and height 1. So that's just a 1. And these are quarters actually. That's a quarter, that's a quarter, and that's a half. So I might just consider the entire thing as 1, just to make my life a bit easier. And then down here we have -1/2 in these two triangles, and plus a quarter over there. Hoping, oh yeah, this is right. This gives us 4 3/4, which is 19/4. Yes, that's the correct answer. Nice. So now we've gone through all of the strange questions on integration, and now we kind of get to the slightly more straightforward ones. Although the maths is actually harder for these, what they want you to do just seemed more straightforward to me. So we've got some nice integration by substitution here. All we're going to do is set u equals sine x, and then du by dx we're going to work out, and that's cos x. So now let's write the integral. Integral of cos x sine cubed x dx is going to equal the integral of cos x u cubed dx. And since we can, if we treat the du by dx as a fraction, which you're technically not supposed to except in certain cases, we can figure out that du is cos x dx. So we can, this entire thing becomes the integral of u cubed du. And that's going to give us u to the power of 4 over 4 plus c. Always remember the plus c. This is, I think, the one question where you do have to remember a plus c. And now, of course, we can go back to what was u again? It was sine x. So we get sine to the power of 4 of x over 4 plus c. And I'm hoping that's the right answer. Yes, it is. These ones shouldn't be too bad. I can go over another one if anybody likes. Now let's go to the definite integral question. So the question here is, evaluate this definite integral. So all we're going to do here is we're going to try using the reverse chain rule, I believe it's called. The idea is that we'd want to say, well, what was this before it was differentiated? And the idea might be, so it was like 3 minus x to the power of 5. But when you differentiate that, you get this. Because you also have to use the chain rule. So, to have that in there, we can divide the entire integral by 1 over minus 5. And now when we integrate this, we already know that that is so now all we're going to do is just evaluate this and really hope that I've got it right. We have 3 minus 1 to the power of 5, take away 3 to the power of 5. Which gives us 2 to the power of 5 is 32. And 3 to the power of 5 is 243, apparently. And if we work this out, we get 211. This works out to minus 211. So we get 211 over 5, which is the correct answer. Great. So this is just like...
Can you solve my question? It's a bit difficult and I got a bit stuck on it.
Oh, sure. Why don't you send me a screenshot? What have we got here? Ooh, it's a...
I mean, it's a bit different. I got a bit stuck on this, so...
Yeah, that is slightly different. Interesting. How are we going to do this?
I mean, yeah.
So... what's the extra brackets there? 2 cos pi x over 2 dx. So I'm guessing that this is something similar and that they want you to consider the chain rule. So if this had been sine pi x over 2, what would that differentiate to? Let's see. That would be cos pi x over 2 multiplied by pi over 2. I'm not sure that's the correct way to approach this one. What I'm thinking is I'm just going to take this 2 out anyway, because that's a constant, can just do that. And then this becomes much more easy to work with in a way. So then if we're using this logic, we needed to have a pi over 2 in here. So we have a 2 times 2 over pi outside, between 1 and 0. Pi over 2 cos of pi x over 2 dx. And this should give us, so then that's 4 over pi multiplied by whatever we'd calculated up there, sine pi x over 2. So that's 4 over pi times sine pi over 2, take away sine 0. Interesting. So we obviously know that sine 0 is going to be 0. Sine pi over 2, what is pi over 2 again? That is 90 degrees. So sine pi over 2 should be 1. So all that is, if I've done this correctly, is 4 over pi. That's a kind of weird answer, though. I'm not super confident in it.
That's what I got as well. Should be.
All right, so that's just what it is. It's just a very strange answer.
Yeah, there's a maybe slightly easier way to think about it, I think.
Oh, probably.
Because, well, you see, if you scroll up a bit, right? So, did you solve it using your, like, you see your thing on the right?
Yeah, I solved it using this
trying to figure
thingy.
out- Okay, you should just be able to do integrate cos, and then times it by 1 over the differential of the thing in the bracket.
Yeah. And I mean, theoretically, that is exactly what this is. This is just thinking about it in a more complex way.
But if you want like a straight method, you should just be able to do integrate cos into sine, and then times it by 1 over pi over 2.
Yeah.
And then that'll get you the same thing.
Yeah. Okay, cool. Thank you very much to Jack for that amazing input. Right, let's get to the very last question then, which is the partial fractions. And this one should actually be, for me, I found it was a decently easy one, if you've obviously learned partial fractions. I guess that can apply to any of the questions though, even the earlier ones, which I didn't know. So let's get right into it. The partial fractions are going to be something over x minus 3 plus something else over x plus 5. Now, if we wanted to add these together, we'd have to get a common denominator, which would be x minus 3 times x plus 5, probably, because we don't know what x is. So we're going to multiply each one by the other one's denominator. So you have a x plus 5 over x minus 3 x plus 5 plus b x minus 3 over the same thing. And obviously we can combine this into a single fraction nicely. Plus b x minus 3 over x minus 3 x plus 5. And now if you see this, you might notice there's a I'm sorry, I'm just going to fix this plus sign because it's the most terrible plus sign I've ever drawn. Now, if we look back at the question, we might see there's a certain similarity between what we've got going on here. This equals that, which equals that, which equals this, and both of these are over x minus 3, x plus 5. So, 3x plus 7, the top of the original fraction, has to equal ax plus 5 plus b x minus 3. Now we're just going to multiply out these brackets to make our lives easier. Ax plus 5a plus bx minus 3b. And now we're going to do something similar to what you might do in complex numbers, where we're going to say, okay, the a plus b has to add up to the x term. So a plus b equals 3. And the 5a and the minus 3b has to equal to the x to the power of 0 term. So we're going to get that 5a minus 3b equals 7. Now we're going to solve these as simultaneous equations. And I think what I'm going to do is actually multiply the first one by 3. So 3a plus 3b equals 9. And then add the second one with this new one. So we're going to have 8a plus 0b, because these ones add together to 0, equals 16. And that's lucky for us, so a equals 2. And now we can just go back to this really simple one and figure out that b equals 1. So the final answer is then, we want to go back to these which we wrote. I really want to do that thing which Stephen Watson does, where he does this and then copy pastes it. So the final answer is 2 over x minus 3 plus 1 over x plus 5. And that's pretty much it. So now we have gone through the entirety of integration core skills. And if you guys have any questions, please do ask them now and we'll try and figure out the solutions together. And otherwise, I shall see you later on the next amazing core skills lecture.